So here we're going to look at this relation where here's our A and here's our B, and we're going to have ordered pairs where X, that XY is in the relation, X is related to Y, if X divides Y. So I don't have to draw an arrow diagram, but I'm just going to because sometimes it's nice to see what we're looking at. So 3, 4, 5, and 4, 4, 5, and 6. Okay, so does 3 divide 4? No. Does 3 divide 5? No. 3 divides 6, right? So 3, 6 is in the relation. 4 divides 4, yes. 4 divides 4. 4 does not divide 5. 4 does not divide 6. So then we've got 5 divides 4. No. 5 divides 5. And that's about it. So not many, I guess I didn't draw all the arrows, but here 5 divides 5. Not many in the relation. So now if I want to find the inverse relation, so those are the ordered pairs in R, right? So these are ordered pairs are in R, and then our inverse would be just the opposite. So 6, 3, 4, 4, oh, and 5, 5. Not much in the opposite direction at all. So now we can have a binary relation, a relation between two sets, but wait a minute, we're going from set A to set A. So this kind of arrow diagram, not necessary because we're going to itself. So all we're going to do is we're going to draw the points. So I'm going to put the elements in the set A, and so I'm going to draw the elements in the set A. And then I'm going to draw arrows, right? A directed graph means arrows. So there's a relation between 0 and 0. So I'm just going to do this arrow loop around 0. And then I've got an arrow from 1 to 2. Oops, I'm sorry, just drawing the wrong place, huh? From 1 to 2, 1 to 2. And then I've got an arrow from 2 to 2. So that's the directed graph. All right, so that was a pretty simple one. So let's try one that's a little more challenging. So here I've got these numbers. So let's draw them far enough apart from each other so that we can draw some arrows. Okay, so now we're going to have a directed graph, an arrow, if 2 divides x minus y. All right, so 2 will divide 5 minus 5, right? 2 will divide 0. And so I can see that for sure we're going to have an arrow back to it, every one to itself, right? Because every one of these numbers, 2 will divide 0. Okay, so then let's look at what we've got. So 2 will divide 5 minus 7, and 2 will divide 7 minus 5. So we have to have our arrows in both directions. And so 2 will divide 6 minus 8, and 2 will divide 8 minus 6. And 2 will divide 6 minus 10, and 10 minus 6. And 2 will divide 7 minus 9, and 9 minus 7. And 2 will divide 10 minus 8, and 8 minus 10. Wow, that's a lot of arrows. Okay, so here, this is pretty important. So I want to make sure that you know what these are. These are definitions of things that are properties that a relation can have. So we say that the relation is reflexive if for every x in the set, x is related to itself. Okay, the symmetric, this says if I have this in the relation, then the reverse is in the relation as well. And transitive says, if I have xy and if I have yz in the relation, then xz is in the relation. Okay, so so some of the relations can have one of the properties, two of the properties, none of the properties, so we just have to go check for every single one. All right, so looking for reflexive first, I see that I have 0, 0, and I see that I have 1, 1. Oh, and I can see the elements in the set are 0, 1, and 2, but I don't see 2, 2 is not here, so not reflexive. Okay, let's look for symmetric. So symmetric, we just have to look every time I have an element like 1 or 0, 1, do I have 1, 0 in there? I do. What about 0, 3? 0, 3 is in there. Is 3, 0? No. So 0, 3 is in R, but 3, 0 is not. So it's not symmetric. Okay, so transitive. Let's look and see. I've got 0, 0 and 0, 1. And does that mean 0, 1 is in the set? Yep. Let me erase some of my marks here. So we can see. So 0, 1's in the set. So we're on the lookout to see if there's one that doesn't work. So let's see. 0, 0, 0, 3. Okay, that's 0, 3. What about 1, 0? If I have 1, 0, and then I have 0, 3. Do I have 1, 3 in the set? No. So not transitive. All right, how about this one? Kind of the simple, stupid one, right? There's like not much there. So reflexive, yeah, it's reflexive because I have the element is related to itself, right? And so that means it's reflexive. Is it symmetric? So for every element I have in here, is the opposite of it? Yeah, it's symmetric. Kind of the silly, stupid case, symmetric. And what about transitive? Well, this is where we call this vacuously true. Remember in the beginning when we talked about truth tables? So it's vacuously true, so really not much there.